Hey everyone, it's Nick. For today's video, what we're going to do is apply a pattern to the vault surface that we've been working with, just to create some openings and some visual interest and just kind of show off what you can do with the laser cutter. And this is going back to one of the earlier videos that we showed when we looked at the Voronoi patterns and the metaballs, and we showed different ways of using curves and points and like random points to basically make a panel. And what we're going to do is we're gonna make multiple panels over the surface, and then as we've been doing, we're going to distribute those parts to a like a laser cut sheet. And going back to what we've done previously, make sure that you're using the same model as you were before when you made the connections, um, and just make sure that it's to scale and everything. And in fact, I think it would really help actually to have the connection model in the file. And in fact, what I'm going to do is I'm going to go ahead and take this script that I gave you and just select it and do Control C. And I'm going to go into my connections model that I've got and go ahead and do Control V. And you can see all this is kind of stuck up here. So I'm going to go ahead and plug this in. Yeah, and move some stuff around here. Okay. But you can move between scripts. Like you can actually copy paste, scripts just like you would anything else. You can see how this pops in here. The only difference is that this surface should probably be connected to this surface. And it won't change anything, but that's exactly the same surface. You just make sure that that's working. Um, and then, lastly, I've got my, yeah, these are probably all connected together. So this one is kind of redundant. No, wait, that's the good one. That's my, these are what the pieces actually look like. This one's a duplicate, so I can just delete that. That's from the same script as before. Go ahead and delete this group. Let's kind of clean things up here. Add to group. There we go. Yeah, okay, curves. So these are my Voronoi, and you can see, they're pretty distributed. Some of them will still not work. I've talked to you guys about this. You might need to edit the file, and that's clear here as well. Um, but basically, this is how you would take this from one script to the other. It's basically just copy paste it, like I said, and just make sure the surface is plugged in, just so that you're working from the same file. And this one's a lot simpler than the connections one. And in fact, it's all stuff you've seen before. We're looking at the familiar, you know, finding planes on a surface, making an attractor system with Lunchbox, um, uh, making Voronoi over a populate geometry. So all that stuff is the same. But I'll go ahead and talk you through it nonetheless. Um, this is how we keep moving on with the project. So again, it's great to have that file in there and have everything turned on. I'm going to go ahead and actually, speaking of which, I'm going to go ahead and turn off some of these previous things from another video. Let's make sure that everything's clean. Yep, all that's in there. Um, Excellent. Okay, so this is what we're looking at. And go all the way back. We got our surface. And for now, I'm actually going to go ahead and hide some things just to make things clear for us. Otherwise, it's going to kind of get in the way of what we're looking at. Okay, I'm keeping these tabs on the connections, and I think you should too, just so you get this next part right. So what we want to do is we want to have a container for our Voronoi points, right? The random points that we could do other geometry too, like circles or something like that, but we've already sort of looked at that before. So we want to put the points in something, but we don't want to do it over the entire surface because we're going to get in the way of the edges of our materials and we're going to get in the way of our tabs. So if you remember, one of the tricks I showed you is that we're going to basically just offset this edge, and that's going to give us a nice kind of clearance here for that other stuff to happen. And that's what this slider is actually, is you can like dynamically, kind of adjust. Don't go too far, and it's going to break. But and again, kind of use your best judgment as to where that's going to fall in terms of the material that you're using, in terms of the shapes that you're going to use. But that's the beauty of the parametric system. Um, why wouldn't we scale things? I've talked about this before. If we just scaled it that's actually not necessarily going to give us the same distance on all sides, just because of the way that shapes work, or the way that centroids are like calculated for polygons. And so I found personally that offset works pretty well. But in order to really get the offset to work best, you do have to join the curves first. So you're going to take the edges from the deconstruct B-rep, from the surface, put them into a join curves. I'm going to go ahead and flatten the data structure, and then that's going to just give you 58 closed, basically closed curves. Offset them, and that again gives me kind of a weird data structure, but I'll work with it. And then remember that the populate geometry doesn't work with curves. It works with surfaces and other forms that are multi-dimensional. So what we actually have to do is use a boundary surface first, and I go ahead and graph that, and then that's what's going to give me my points. And to figure out how many points I have, I just make a little attractor system, and it starts with the attractor component that's part of Lunchbox. So you go into generate attractor, or just attractor, okay? And then we've got a deconstruct point and a construct point, because what that's going to give us, as you guys saw before, is, and there's different ways of generating the attractor, but I kind of create like a pattern on the ground to work with. Otherwise, the distance gets kind of strange, but you can do what you like. We have a bounds component, sorry, a construct domain component for the domain. So this says what's the maximum number of points that we want randomly. So if I increase this, I'm going to get more points in the random cells, and the minimum number of points in a cell. And it's totally up to you how many points you want, like what kind of design you want. But that's what those sliders like indicate. And then in order to get this to work, though, remember we have to have an attractor. And what I actually did was that I placed a point object in the system. Hide these. So I just make a point, and then go ahead and go attractor, set point, and then click the point. And then what that gives you is that gives you the ability to actually move the point, and you can see how it's going to change that distribution. Go ahead. Let's see. Invert selection. I should have done that first. Not very computational, sorry. Okay, so anyway, that gives you a little bit of control over it, if you want to open up an area. You could try some other things, but that's what I've shown you before, and so that's something that I think you could probably do without too much trouble. So that's that point. So that's what the attractor gives you, and the attractor will give you, basically, it'll say, okay, how many random numbers per cell or per face do you want? Okay, and then I plug that into the Voronoi. And for the Voronoi, remember you want to have base plane, so I'm going to take the frames, I should say. So the Voronoi need to have a frame, so we get the frame from the surface as we always do, take the centroid, find the closest point on the surface to that centroid, take the UV coordinates, take evaluate surface, and that gives you the frame. Okay, you can see these are all the frames. It's done this a bunch, so that's a really common pattern, right? And then we create the Voronoi, and they're huge and terrible. But then what we're going to do is we use the region intersection between the Voronoi, so the region of the Voronoi and the region of the outer curve, right? Of the offset curve, and that will give you the cut, right? And from here you could do different things. Like you could actually just go ahead and offset these curves, or you could go ahead and just scale them down. What I've actually been doing, what I've shown you guys, actually real quick, I'm managing the data structures here. So the data comes in, all these are just 58, 58. And then what comes out, you can see that there's multiple points for each container. So I just simplify it. And then, so that's what I end up with. I have 57 containers. Here I graphed it, because again, these come in as just 58 or 57 things. So that they match. Now I've got, these cells, and then here I simplify it, and here the data is coming in, and I have to graph it. So these two things have to agree with each other. Okay, so then once we've done that before, so I've got those, and then what I do is I'm going to rebuild. I'm going to find the center of each one. I'm going to scale these. These I do scale. I'm not going to offset them because I am actually interested in what happens with the rebuilding. Okay, so and then rebuild them, and we've seen that pattern before, and that's how you get those kind of organic shapes out of them. Just kind of a quick way to do that, right? But you could actually see at that other point where you might actually get um, as a difference between, you might actually end up with something like this, and that's good. That could be kind of interesting if you turned off the offset curve. You could laser cut those. But I'm gonna go ahead and make them organic just for fun. So, all right. And okay, so once you've got that, if you want to visualize it in the model, like that's actually something I think you might want to see. Like if you actually want to see them as like holes, this is a merge component. And the problem is that in order to get a boundary surface to subtract these things, you need the outer edge and all of the collected inner edges, and they all need to match each other in terms of the data structure. And so I take the outer curves here, big surprise, like that's the outer curve. And then I take all of my internal curves, and then the merge basically puts them together. So if they match, you can see I've got one curve for each, and now I've got like 15, 13, 13, 16. Well, now it's gonna be 16, 14, 14, so I've added that outer curve, and now the boundary surface knows to put those together. And that's all that is. And I just did that in case you guys want to make for your drawing of the project. That's gonna probably be handy. If you want to cast shadows and stuff like that, you're gonna want that. So anyway, that's what that belongs to. Um, take the same structure we had before in terms of the orient component. Just copy paste it, and you can keep all the stuff from before. It's even the same planes for the A, but then just obviously go ahead and pipe in your rounded edges, and that goes on your cut sheet, right? That's all still working together. But again, you've got some weird stuff here, so just make sure to take care of that, on the sheet. But that's how you get openings. That's the next part. Okay, last part of this, we're gonna go ahead and nest everything, and then you'll put your labels and your tabs back on it, or labels and dots, and you should be good to go. All right, take it easy.